Okay, today's our third day on the foldable that's titled Unit 11 Solving Quadratics. We're going to spend another day on factoring. I just want to talk about some questions that are just slightly different from yesterday. And again, try to recap what factoring actually is. Okay, this is our first new problem. Again, it's going to be in the factoring part of your foldable. What's different from this problem than yesterday is you don't see a zero on one of the sides. And you need to have one of the sides equal 0 because that's your main goal, is to solve for the x values or whatever variable you're talking about that's going to give you about an answer of 0. So if I look at this, okay, I need to get 0 on one side. So what I'm going to do is I'm going to move 8t to the other side of the problem by subtracting. What happens when I do that is I get 0 on one side of the problem. And so what I can do is I can go ahead and use factoring to rewrite this right side of the problem as a multiplication problem. That's the whole goal of factoring. Factoring is to rewrite a problem so it uses multiplication. Okay, so what I'm going to do that is I'm going to factor out the greatest common factor of 16t squared and 8t. Okay, and that should be 8t. So I'm going to take out an 8t. And when I do that, I'm going to write what I have left. And what I have left when I take an 8t out, from the first term, I'm going to have a 2t left. And then the second term, I'm going to have a 1. Okay, so that's what it would factor out to. And again, the nice thing about factoring is it rewrites it as multiplication. In this case, I'm multiplying two things. I'm multiplying 8t and 2t minus 1. So if either one of those equals 0, the whole thing is going to equal 0, which is my goal, is figuring out what the value of t is that's going to make the whole thing be 0. So if I set 8t equal to 0, and I divide both sides by 8, you figure out that one of your answers is 0. Okay? And so you might be saying, well, yeah, if I put 0 in for t where 8t is, I get 0. But if I put 0 in for 2t minus 1, I only get negative 1. That's fine. 0 times negative 1 is still 0. If I take my second thing that I was multiplying, 2t minus 1, and I set that equal to 0 and solve, I'll add 1 to the other side. So 2t equals 1. And then when I divide by 2, you figure out that your other answer is 1/2. What's nice about this is I can actually check with graphing. If I were to graph the original problem when I move the terms, okay, and had 0 on one side, then the graph should cross the x-axis at 0 and 1/2. So I want to go ahead and show you that. Okay, before I type this in, I know I'm supposed to have an answer of 0 and 1/2. So here's where x is 0. I'll put a dot. And when x is 1/2, it's really close to that, so I'll put a dot there. So what that means is when I do graph the original problem after I move the terms, okay, it should cut through both of those. So let's go up to y equals. I believe the original problem was 16t squared, which I can use x, and then minus 8t or 8x. And again, when I hit graph, okay, notice how the graph goes through both of those answers. That's how I know the answers are 1/2 and 0. I can always check with the graph. Okay, here's my second example and the last one that I'm going to do in the foldable for you guys. On this problem, we already talked about it's beneficial to have 0 on one side, so you're actually figuring out what values of the variable give you an answer of 0. So I'm going to start off by rewriting it. I'm going to move negative 12 over to the left side, so it'll become positive 12. And that way I have equals 0 on the other side. Okay, so the next thing you need to look at is right now it doesn't have multiplication. So I'm going to change this to a multiplication problem by factoring. So this is a trinomial. It's a trinomial that's going to involve a t-chart. So just to kind of recap a t-chart, I need to figure out what's going to multiply to give me a times c. And the same two numbers have to add to give me b. A times c in this case is 2 times 12, which is 24. And b in this case is negative 11. So the two numbers that multiply to give me positive 24 and add to give you negative 11 are negative 3 and negative 8. So unfortunately, this problem doesn't have a shortcut. Okay, because I have a 2 in front of the w squared. Anytime you have a number other than 1, okay, what you're going to have to do is change it to a grouping problem. So if you remember, what you do is you bring the first term out, make it the same. Bring the last term out, make it the same. But you're going to divide the middle term or split the middle term up into what you got from the t-chart. So I'm going to make that minus 3w minus 8w, okay, for that. So what I did is I created 4 terms so I can use grouping. So these first 2 terms, they have a w in common. So when I take a w out of both, I am left with 2w minus 3. Okay, and what that means is when I group the last 2 terms, or pair the last 2 terms, and take out the greatest common factor, I should have a 2w minus 3 again. Okay, so to do that, you can figure out you're really taking out a negative 3. I'm sorry, negative 4. I wrote it backwards. Write that again. I'm going to take out a negative 4. All right, when I do that, you take out that negative 4, I end up getting 2w minus 3 again. So 2w minus 3. Okay, notice how you have 2w minus 3 in common. So I will write that out front. So they both have a 2w minus 3 in common. When I take that out of both, I am left with a w in the first one and a minus 4 in the second one. Okay, so that's what it would factor out to. I'm not done yet. I'm trying to figure out what makes this problem equal to 0, what value is a w. Since it's written as multiplication, I can set each thing equal to 0 and solve. Okay, so in this case, when w is 4, that set of parentheses would equal 0. On this one, when w is 3 halves, okay, that parentheses would equal 0. So those should be my 2 answers for the problem. Okay, you can go ahead and graph them, and you'll see that the graph should pass through when x is positive 4 and positive 3 halves.